Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy.
Okay, for the next one's kind of hard. Problem 3. I want to find the area between y equals 14 minus x squared and y equals x squared minus 4. Now this one's not easy to draw, but I'm going to ask if there's anyone out there in the audience of the 17, the 16 of you? Yeah, the 17 of you. Do any of you know what I would draw for this function?
Wouldn't you just have 14 and 4 as the y-intercepts on like a parabola, or no?
Okay, let me do what you just said, because you're off to a good start. Negative 4 is one y-intercept, 14 is the other. And then?
Oh, wait, and then the first function would have a downward cave?
Are you saying that because it's negative x squared?
Yeah.
Okay.
And then the other one would have it like going the opposite way?
You're saying up because it's positive x squared?
Yeah.
This is correct. And again, if you didn't know this, it's not the end of the world. We can still solve this integral using the number line method, which I can do that for this one too, just to show you both ways. But we can see here we're going to have two intersection points. Even if you didn't know we had two intersection points, we could still solve this integral by setting the functions equal to each other. Oh, and the red in this case is y equals 14 minus x squared. The blue is y equals x squared minus 4. I'm sure you guys remember to bring your colored pencils to this one. I told you in the email. Yeah, that's a joke. I'm sorry. Oh well. So this integral, well, before I take the integral, if I set the functions equal to each other, I get 14 minus x squared equals x squared minus 4. How on earth do I solve this one? What I'm going to do is I'm going to add x squared to both sides, and I'm going to subtract 14 to both sides. What I end up getting on the left is 0. On the right, I'm going to have, and I'm going to simplify this in one step, 2x squared minus 18. Now, if I want to, I can actually add 18 to both sides, or I can factor out a 2. Let's factor out a 2. 0 equals 2 times quantity x squared minus 9. The 2 doesn't matter. Like this 2 I can legitimately forget about for the rest of the problem. Why? Because, well, 2 does not have x in it. All I care about is the x squared minus 9 at this point. X squared minus 9 equals 0. This can be factored to x plus 3, and x minus 3 equals 0. Alternatively, if you wanted to, you could also say x squared equals positive 9, like I added 9 to both sides, and then you take the square root here. There's many ways to solve this problem, whatever way you feel comfortable with. Either way, you're going to get x equals positive 3 and negative 3 as our intersection points. Any questions so far? Okay, so going back to my picture, I have here is negative 3, here is positive 3. I can see which function's on top. It's going to be the 14 minus x squared. But what would I do if I had no idea? Again, make a number line. Make a number line. Here's negative 3. Here's positive 3. In this case, there's only one region we care about. It's between negative 3 and positive 3. So you need to pick a point between those two numbers. The easiest one is obviously 0 here. And you're going to plug it into both functions. Y equals 14 minus x squared and y equals x squared minus 4. We plug in 0 into both. What would we get? So you plug in 0. You get y equals 14 minus 0, so 14. For the other one, you get y equals 0 minus 4, so negative 4. Obviously, 14 is higher in this case, so the top function, again, is going to be y equals 14 minus x squared. That's the first function in my integral, is 14 minus x squared. Any questions? I'm sure a lot of you have questions, and you don't necessarily know what to ask. And the other half of you are thinking right now that this kind of makes sense, but you really won't know until you do these problems on your own. Well, guess what? I have my Calculus for Dummies book with me with the written out solutions. So what I'm going to do for you is, after this lesson's over, I'm a nice guy, and I'm going to take a picture of that entire page of problems. I'm going to send it to you guys, and if you want the solutions, you can send me an email. Just so I don't because I'm worried whenever I give people the solutions right away, I know you guys are just going to cheat, whether Whether you think you will or not, I have no faith in you. I have zero trust in you. I think you're all a bunch of cheating liars who during the Zoom lectures, I'm sure all of you cheated on the exams. I have absolutely no faith that you have any integrity whatsoever. And if you do, I'm not talking about you, obviously. If you have integrity, I'm not talking about you. But for those of you who don't have integrity and you did cheat, you're cheaters. That's my big insult at the end of that. So now we have the integral from -3 to +3 of the top function is +14 minus x squared minus the bottom function. I need to have a quantity here. Quantity x squared minus 4. I do need to be careful there. I am going to have to distribute that negative sign to both terms. So this integral will become the following. Integral from -3 to +3 of 14 minus -4. Everyone see that? I have 14 minus a -4. That's going to be 14 plus 4, so that will become 18. And then minus x squared minus a second x squared dx. So if I simplify that, I get integral from -3 to +3 of +18 minus 2x squared dx. By the way, if you ever get a negative answer in any of these integrals, it means you chose the wrong function as the top function. You should always get a positive area because, well, area needs to be positive. And if you got a negative area, it means you chose the wrong thing to be the top function. So that's actually a nice way of checking. So we're going to get the following. If I take the integral of this, the integral of 18 is just 18x minus 2 times integral of x squared is x cubed over 3. Parentheses around this for notation purposes, and then long bar evaluated from 3 to -3. Once again, I need to plug in. There's going to be a lot of plugging in tonight. But 3 times 18 is 54. 54 minus 2 times 3 cubed over 3 is 9. And then minus the quantity. 18 times -3 is -54. Minus 2 times -3 cubed over 3 is actually -9. So we put this all together. You're going to get 54 minus 18 minus the quantity -54 plus 18. So it looks like this stuff almost cancels out. It kind of does. It ends up being 54 minus 18 plus 54 minus 18. It's again a symmetrical case. But you're going to get 108 minus 36. And the final answer, I'm actually terrible with subtraction. I think it's 72. 72 is our final answer. Any questions? And again, positive 72, which means I chose the right function as the top.
So if you choose the wrong way, would it just be a -72?
Yeah, and I'm kind of realizing it just now that it's that easy. Yes.
Okay.
Of course, I mean, there's a chance that you made a math error along the way and like everything's wrong. But assuming the math is right and the only mistake you made was you flipped the top and the bottom wrong, then the answer will just be -72. Okay, here's the next one. Y equals -x plus 3. Oh, this is number what? Number 4. Y equals -x plus 3. Y equals 0. And x equals 7. So this one's not too bad to draw. We can draw this one. We're going to have y equals -x plus 3. I'm going to draw that in red here. It looks something like this. The line y equals 0 is actually the y-axis. I can draw that in blue. It's literally the y-axis. I'm sorry, the x-axis. It's the x-axis. And then x equals 7. I mean, we don't know exactly where it's going to be, but it's probably going to be somewhere over here. I need to extend this a little bit longer, as you can see. But it's going to be somewhere around there. So now my region is bounded by 3 functions. It's this right here. And this time I have 3 intersection points because I have 3 functions. 1 intersection point here, 1 intersection point there, and 1 intersection point there. Now, in order to find the intersection points for this one, I'm not going to set all the functions equal to each other, especially not x equals 7, because, well, that's not y equals. You only set the y equals equal to each other. X equals 7, actually, that's going to be my last bound. Like, these points right here, this is x equals 7. I really just need to find this intersection point where the blue and the red meet each other. I forgot to label these points again. The red is y equals -x plus 3. The blue is y equals 0. It's also the x-axis. And the purple is x equals 7. Any questions so far?
Yeah, I have a question.
Go for it.
So if you couldn't draw the graph,
Yep.
Would you still be able to figure out like which one's on top, even though one of them is like x equals, or no?
Yes, because x equals 7 will never be on top. That's like the
Okay.
right or the left.
Okay,
See what I'm
so you
saying?
would still just do the same thing with the number line?
Yes. And I'll
Okay.
show you what you would do differently. Like, let's say you couldn't draw this, but they give you x equals 7 or x equals whatever. I'll show you what to do.
Okay.
But don't set them equal to each other.
Okay.
So here's what we do. We set the y's equal to each other for sure. Negative x plus 3 equals 0. This is actually the easiest case we've seen tonight. 3 equals x. Great. There's 3. Now, that x equals 7, that tells me what the bound is. If I give you x equals whatever, 7, negative 2, pi squared, that's telling me the x value, the bounds. The bounds. So right away, I know my integral is going to be the integral from 3 to 7. Again, because 3 is the first intersection point, they gave me x equals 7, which is the other bound. Any questions so far? So again, if we were to figure out which function's on top, let's say we don't know, and we make a number line, you don't put 7 on the number line. You only, actually no, technically you have to, but you put 3 and 7 here, but you're testing a point in between 3 and 7. You don't plug into x equals 7, you're only plugging into the y equals values. I repeat, 7 goes on the number line because it's an x point, but you're not plugging into the function because it's not y equals. You only plug into y equals. And again, you're going to get better at this over time. The more problems you do on your own, the better you're going to get. And that's actually one thing I wanted to mention earlier, is if you plan on coming to the Sunday review session, please tell me sooner rather than later. Space is limited. Yes, that is a marketing trick. I mean, obviously, there's no limit to an online class. But if I say space is limited, it tricks your brain into signing up sooner. And I'm pretty sure you guys are dumb enough that you'll fall for that trick. Ha ha ha. But seriously, if you want to come to that Sunday session and you're planning on saving all your studying for Sunday, I think you're an idiot. I think you're a loser. I hope you fail the test. I want you guys to study before Sunday. I'm hoping that the Sunday review is really just tying up loose ends that you still might have. Okay? I think we all know that, but sometimes I need to say it anyway, because if I don't, you guys will actually not study except for Sunday, which is bonkers to me. Okay. So again, we need to plug in a point between 3 and 7 into each function. If we plug in a number like 4 into y equals negative x plus 3, it would become negative 4 plus 3, so negative 1. And then the other function's y equals 0. I can't plug in for x. It's always going to be 0. But which number is bigger, 0 or negative 1? It's 0. So y equals 0 is on top. And again, if you didn't draw it, well, this proves it. So here we go. We have integral from 3 to 7, my x points are 3 and 7, of 0 minus quantity negative x plus 3 dx. What you're going to see is even though 0 isn't the integral, the reason that shows up in this integral essentially serves the purpose of making your final answer positive. In other words, if I, again, miss the order, I'm just going to get a negative answer. And real quick, again, I want to talk about this because look at this area. This area looks like it should be negative, right? It's below the x-axis. However, there's a reason why when we say area between curves, we want the area to always be positive. And because of that, we have to make a new definite integral to kind of force it to be positive. That's what's going on here. Any questions on what I just said? I know it's a lot of words.
Yeah, if we just put our answer as like an absolute value at the end, if we get a negative number, do you think they're going to dock off points on the exam?
Oh, that's a good question. So I'm going to answer two parts of that, actually. So the first thing I want to say is there's a chance where they know how annoying it is to just plug in the numbers. Like I've been taking a lot of integrals today, obviously. But there's a chance they just want you to set up the integral. And if they do that, then you won't know if your final answer is positive or negative, right? Because you won't actually be solving the integral. So in a way, you do need to know which function's on top and which one's on the bottom. Now, to actually answer your question, let's say they do ask you, solve this integral. Like, tell me what the integral is, set it up, and then solve it too, and you get like a negative 5 instead of a positive 5. Seriously, if I were you, don't just be lazy. Don't just put the absolute value sign. Actually go back and say, oh, the other function was on top. Fix your work, because there's a chance, obviously, you get points docked off if you just put an absolute value sign at the end. You know what I'm saying?
Yeah, thank you.
Yep. Any other questions? So honestly, like just for the rest of the problems tonight, just because I think you get what's going on here. I'm just going to leave this as the final integral, and you can solve this on your own if you want. But really the most important part is, can you set up the integral? Obviously, the last quiz we focused on actually solving the integrals, but setting up the integrals is the hard part for most of these problems. Are you guys all okay with that? If you want, I can actually solve it, but I'm pretty sure no one wants me to do that, except me, of course, because I love math. Did I ever mention I won the math award at my high school? Out of 600 students. Well, technically 598, but who's counting? Okay. Springford High School, by the way, in Montgomery County, Pennsylvania. Debatably one of the best high schools in the country for calculus. The reason I say that, I think I've told this to some of you before. I'm not sure if the whole group. But when I took calculus back in high school, it was junior year, and I remember towards the beginning of the semester, my teacher, Mrs. Artsaronian, Kelly Artsaronian, the greatest calculus teacher in probably the whole country, she told us that 80% of her students don't just pass the exam but get 5s on the AP Calculus exam. To put this in perspective, about half the students who take the exam, 50%, fail it altogether. They don't even get a 3. 80% of her students get a 5, and then on the Calc BC exam, which I also took, 90% of her students get 5s. I'm telling you, I've never heard numbers like that in any course out there. I had an amazing high school, even though it was public. It was literally a public high school. But I had an awesome math department, which is why I guess I'm doing it right now, because I genuinely love it. Okay, enough. I go on a lot of side tangents and a lot of bragging about myself, but it's for good reason. It's because I'm awesome. Now for number 5. Y equals x and y equals x cubed. 2 more problems tonight, and then you can go back to studying or whatever you do on Tuesday nights. So for this one, again, I can draw a picture. Maybe you don't know what this looks like. Maybe you do. I'm going to help you out for this one. Let's assume it's test day, and hopefully you know what the graph looks like. It looks like this. Y equals x is just a straight line that looks like this. Y equals x. Y equals x cubed is kind of a funny looking one, but it's going to look like this. Need to be careful here. I think, yeah, this is good. Y equals x cubed. You can see once again we're going to have 2 regions here. And again, this case will be symmetrical, so if I wanted to, I could just double it, the area. Even though one's positive and the other's negative, since I'm going to make the area positive anyway, I can just say it's double. Now, do I recommend you saying it's double? Probably not, because there's probably some kind of proof that's technically involved here, and I couldn't tell you what the proof is. I've just seen this problem enough times that I know it's symmetrical. But it's not that hard to draw the 2 integrals. I would just say make the 2 integrals. Now, the one thing that's hard about this one in particular is we have 2 functions, right? We can look at this and we can say which function's on top, which one's on the bottom, but how do we find these intersection points? There's 3 intersection points in this example. Obviously, we're going to set the functions equal to each other, but again, this is not the easiest one in the world. You get x equals x cubed. Now, one more time, a lot of you will make this mistake. Hopefully, me making it for the 3rd time tonight will make sure that you don't make it on your own. But let's say you do. Let's say you cancel out the x's. You get 0 equals x squared or 1 equals x squared or whatever you get. Don't cancel out the x's. Don't cancel out the x's. Instead, subtract x from each side, and then we're going to factor out the common term. So 0 equals x cubed minus x. Factor out the common term. It's x. So x times quantity x squared minus 1. Look at that. X squared minus 1 can also be factored. We'll get 0 equals x times x plus 1 times x minus 1 times x minus 1. We get x equals 0, positive 1, and negative 1. Those are my 3 x points, which I'm going to draw on the graph right now. Any questions so far? So once again, in the scenario where I have 3 intersection points, I am going to need 2 integrals. The integral from negative 1 to 0, and then I'm going to give myself some space, and then I'm going to say plus the integral from 0 to 1. And now let's fill in this. So negative 1 to 0. Again, just looking at the graph, I can see y equals x cubed is on top and y equals x is on the bottom. But again, let's say you don't see that. Let's say you miss it. Then what am I going to do? I'm going to make a number line. I'm going to say negative 1, 0, and positive 1. And I don't care about the outer cases. I only care about the 2 cases in the middle, because that's the only spot I need to figure out where the function's on top and on the bottom. So we have the two functions y equals x and y equals x cubed. This is not easy, but first I would plug in a number like -1/2. So y equals -1/2 and y equals -1/2 quantity cubed, which is actually -1/8. Now here's the thing. -1/2 is a bigger fraction than -1/8, which means since it's a bigger negative fraction, -1/8 is a more positive number. And in case if you're curious what I mean by that, what I'm saying is, I'm just going to scroll up. If you look at -1/2, here's -1/8 as our y point, and here's -1/2. Which number is more positive? In other words, which one's on top? It's the blue. -1/8 is more positive than -1/2. Does everyone see what I mean by that? Is it confusing? Yes. Hopefully you see it enough times before the test that you're not worried about it. In other words, for -1 to 0, y equals x cubed, that's the function that's on top. Now from 0 to 1, you're going to see it's the opposite. Y equals 1/2 and y equals +1/2 cubed, which is +1/8. Now +1/2 is more positive than 1/8. So y equals x is on top in the region between 0 and 1. So ultimately this comes down to this, what I'm saying. Integral from -1 to 0 is going to be the top function, which is x cubed, minus the bottom function, which is x, dx, plus the integral from 0 to 1 of the opposite. Now x is on top minus x cubed on the bottom, dx. And again, I can solve these two integrals. I trust that you can do that on your own. It would take like 15 minutes probably, but I know you can do it. So I'm just going to write out the integral and let you do that on your own if you're so inclined to do so. Any questions so far? Well, I get this is it for the problem. That's all I'm going to look at. But any questions on number 5? Okay. Now we're going to look at the last problem of the night, number 6. Y equals x cubed minus x and y equals 2x. I'm going to tell you right now, y equals 2x you can probably draw. Y equals x cubed minus x. I don't even know how to draw that without looking at a graph. And if you want, you can like plug in points. You can plug in -1, 0, and +1, and whatever other points you want to check. But I'm telling you right now, for this one, this is not easy to draw. This is a perfect example of you don't need a graph to solve it. I don't need a graph to solve it. I'm going to do the method where I plug in. I'm going to set the functions equal to each other. I'm going to see which one's on top and which one's on the bottom by plugging in numbers into the number line, and that's what I'm going to do. Y equals x cubed minus x, y equals 2x. So again, we cannot set these two functions equal to each other. I mean, that's what we're going to do. We cannot draw a graph. So I'm going to say x cubed minus x equals 2x. Hopefully you know by now what we're going to do. I'm going to subtract 2x from both sides. I get x cubed minus 3x equals 0. And then I need to factor out the common term, which is x. So x squared minus 3 equals 0. This is not a fun problem. Oh well. So x squared minus 3 does not solve very nicely. But we get x equals 0 for the one solution. The other one, x squared minus 3 equals 0. To solve for that, what I need to do is add 3 to both sides. So we get x squared equals positive 3. And then I need to take the square root. But whenever I take the square root, don't forget it's plus or minus, right? So x is going to equal positive square root of 3 and negative square root of 3. So there's my 3 intersection points. Even though I can't draw it, I'm still kind of going in blind here. If I make a number line, I have negative square root of 3, 0, and positive square root of 3. These are my 3 points. Which, if you didn't know, square root of 3 is equal to about 1.7, which means I can plug in -1 and +1 here for my points in the middle. It's actually not too bad. So again, the functions are y equals x cubed minus x and y equals 2x. First, let's plug in, was that right? Yeah. First, let's plug in -1. So y equals -1 cubed minus -1. That's going to be -1 plus 1, we get 0. For y equals -1 into 2x, we get y equals 2 times -1, you get -2. Which function's more positive? It's x cubed minus x. X cubed minus x is on top for the region between -3 and 0. Again, this has 3 intersection points, which means I'm going to have 2 integrals, 2 areas to add together. And then for my other point, I'm going to plug in +1. So y equals +1 cubed minus 1, that's 0. And then the other one's y equals 2 times +1, which is 2. Y equals 2x will be on top between 0 and √3. So if I were to set up my integral, and again, I'm not going to solve it, I'm just going to set it up. It's going to be the integral from -√3 to 0 of the first top function is x cubed minus x, and then minus 2x. And then and then dx. And then the second integral, it's going to be the opposite. The integral from 0 to √3 of the top function 2x minus quantity x cubed minus x, close parenthesis, dx. I'm going to circle this. This is my final answer. You can stick around for questions if you want.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.